We are doing August 2022, question number 4B. August 2022. Question number 4, boy. August 2022, question number 4, boy. Once you get this question, could you kindly say why for yes? Why for yes? Hope you have your past paper. All right. So already they have it. Thank you so much. So we read this. Mwamba County water treatment plant purchases 100 kilograms of lime bags for use in the water treatment process. The number of bags used per day varies on the basis of water consumption. Examination of past records discloses the following data. So you can see usage during a past reorder period, number of bags. And then we have number of times this quantity was used. The economic order quantity has been established at 2,500 units with an average daily usage of 25 bags and a lead time of 15 days for its single product X. Additional information, the optimum number of orders are 6. Normal carrying cost is 50. Remember, carrying cost is the same as what here? Holding cost. So step number 1, give us the probabilistic distribution. Give us the probabilistic distribution. Probabilistic distribution of demand during lead time. During lead time. During lead time. So this one, of course, has an association with what we call reorder point, or reorder levels. Reorder point or reorder level. Because if you remember very well, I gave you a formula for getting reorder level. Is there somebody who is able to remember that formula for getting reorder level? Anybody who is able to remember that formula for getting reorder level? I've been able to remember very well that whenever we talk of reorder point, not write this, but whenever we talk of reorder point, we are basically looking at the consumption during lead time. Consumption during lead time or demand during lead time. Demand during lead time. Very, very important for you to know that. So like now this examiner has given me this DDLT, demand during lead time. Demand during lead time, you can see usage. Usage is the same as demand. Yeah, usage is the same as demand. Yeah, during past reorder period. So during past lead times. So this DDLT has been given. It is 225. It is 300. It is 375. It is 450. It is 525. It is 600. 600. And then they have given me number of times. Number of times. This is also known as frequency. So number of times has been provided there. What do we have, my great students, as number of times? So the number of times that we have, the first one there is 9, 15, 20, 3, 2, 1. Giving us what total? Somebody here? Giving us what total? 50, isn't it? So out of these frequencies, now we can easily get what we call probabilities. Probabilities by relating the individual frequencies to the total. Yeah, by relating. So like now this will be 9 over 50, 15 over 50, 20 over 50, 3 over 50, 2 over 50, 1 over 50, which will end up giving us what figure? Which will end up giving us so 0.18, 0.3, 0.4. 0.18, 0.3, 0.4. 0.18, 0.3, 0.4, 0.6. Oh, it can't be 0.63 or 0.06, yes. 0.06, yeah. 2 over 50 will be a very, very small number. Is it 0.01? 0.04, okay, yeah, it's not 100. 0.04, and then lastly 1 over 50, 0.02 now, 0.02, 0.02, like that. So remember, these are all the demands. But for our case, now in my next table, which is a stock out table, or what we call supply demand table, yeah, I know where I'm going to start from. I must cut away some of these irrelevant demands. So this table, first of all, this is the bedrock. This is demand during lead time. Have we been able to draw it? Now, once you draw it, ladies and gentlemen, now you can go and give us there. Now that payoff table, yeah, a stock out, payoff table, a stock out, payoff table, a stock out, payoff, yeah, table, where basically we compare demand versus what here? Supply. You can call it demand supply table, whichever name you want to use. Yeah, so you're going to copy this exactly here. So you're going to have here your DDLT. But now remember, this time round, I'm not going to start from 225. For this stock payout table, where should I start from? Where should I start from? They are saying Mwalimu start from 300. They are saying Mwalimu start from 300. How are they getting that 300? 375, start from 375. The current Melvis, you are very good. I think this person called Melvis, I should give them a present. Yeah. So in this case here, the starting point should be the current reorder level. The current reorder level. Reorder level. I.e., the level, the reorder level, the reorder level, the reorder level without safety stocks, without any safety stock, without any safety stock. So would you kindly do me a favor, please? Write this, and if possible, please give it a yellow highlighter. Use color yellow. Color yellow is the one that produces presidents, Use color yellow. Highlight this. So where do we start from? Which demand do we pick? We shall pick, in this case, that demand that doesn't have any safety stock. Any safety stock. They're telling me Mwalimu start with 300. So the question is, the students who are saying Mwalimu start with 300, where are you getting your 300 from? Are you making reference to number one? Please, in this case here, try to also combine a little bit. Where are you getting 300 from? Perhaps you have something to learn from you. Please talk to me. The way you talk to your father, you talk to your father in a way that you don't fear. Where are you getting this 300 from? Additional information one, you see that is not quantity. That is not quantity, Lavi. You see, this demand is always in terms of what here? In terms of units. How do we get this reorder point or reorder level? You ninjas, you have already given me a formula. You've told me, Mwalimu here, take demand, like in this case, it will be demand per day times lead time days, times lead time days. That's how we get reorder level. So the demand per day in this question, I can see on this note before additional information that the demand, the average daily usage is 25 bags. Please, DD stands for demand, DD stands for demand. So this is 25 every day times lead time days, which on the same additional information, before additional information paragraph, we can see the lead time is 15 days. The lead time is 15 days, like that. So then this one here will end up giving us 375. This will end up giving us 375. So as I write my numbers, I will begin. This is the starting reorder level, this 375. So I'll be able to run with the ball here. Yeah, because I will never have any stock outs with this. No stock outs totally. So I will start from here. So when I write here, ladies and gentlemen, this demand versus supply table, yeah, I can't start from the very beginning. I'm beginning here with 375, like that, 375, and then I write all the others. I write all the others downwards. So 375, then we have 450, then we have 525, then we have here 600, like that. And then their probabilities are given. Their probabilities are given. Their probabilities are given. So we come here and write probabilities. So probabilities of 375, I know the probability is 0.4. Yeah, probability of 450, I know the probability is 0.06. Probability of 525, I can see it is 0.04, and then I can see the last one is 0.02, like that. So remember, now I'm looking at the safety stocks. And the safety stock that I'll be putting in place is to ensure that we don't have any stock out. I don't have any stock out. I don't have any stock out. So then once you write this, you'll be able to come and copy these exact figures just to match the economics principle. Demand versus what here? Supply. So please come here and give us our supply numbers. So we have here 375, 450, we have 525, then we have 600. So these are supply figures like that. You do a good stock out table, a good stock out table, a good stock out table. Do a good stock out table. You guys are lucky because your books have these lines. You don't have to draw them. Yeah. Yeah. Record, yeah, I'm recording. Thanks for the reminder. Not unless there is a problem here, I'm recording. I am recording. Yeah, and in case, please, you have a question that you've been able to shoot up there that I haven't seen, don't think that I'm ignoring them. I don't ignore questions. So in case you shoot a question that I don't get to see, keep on always tagging me. Always tag me. And then, of course, my students as well, they at times help me to answer some of them. Handling a class of 140 students is not a mean feat. It's not a mean feat. All right. So then let's now look at the possibilities. So if we supply 375, yeah, and then the demand is 375, how many do we disappoint? 0, none. Thank you so much. 0. Now, you run this race down. We run this race down. Actually, the very best discovery I've done this time round is to interchange. Initially we used to do it this side. No. You run the race down, the column down. If we supply 375 and we have 450 demanding, so the difference you subtract, how much shall we disappoint? Remember, we are doing the stock outs. Yeah. The disappointments, 75, I'm told. If I supply 375 and they come 525, so you take 375 minus 525. You give me an answer. Somebody's giving me 150. And then 375 versus 600. How many do I disappoint? 225, like that. 225, like that. And then now you come and run this other race of 450. The same procedure. Same procedure. Same procedure. Jeff is telling me that, Mwalimu, if you supply 450 and then we have 375 customers coming demanding our goods, we shall be able to serve all of them. Yeah, all of them will be served. So in this case here, we will disappoint none. So remember, this is about stock outs. If I supply 450 and they come 450, that is perfect scenario for me. I will be able to serve everybody. I disappoint none. But if I supply 450 and then these ninjas come 525, they will really ambush me. Yeah, then in this case here, I will disappoint 75, 450 versus 600. I will end up disappointing how many? 150. I will end up disappointing 150. I will end up disappointing 150. How about this one? If you if you supply 525, today Rina is not talking. Even Geoffrey Karani, my friend, used to talk quite a lot. Today, no. Let me try to identify the ninjas who have been talking. And today they don't want to talk. Yeah, great. So if it's 525, of course, this will be 0, 0, including this is 0. Yeah. And then, of course, if I deliver 525 and then they come 600, then I will disappoint how many? 75. And then even if you understand nothing, the very last one is normally what here? Zeros. So now, having done that, could you kindly tell me what will be the next thing to be done? Kindly advise me. What shall be the next thing that Mwalimu will do? Or is that everything? Is that everything? Is that everything? Will that be everything? What do you think will be the next thing that Mwalimu should do? Averaging, yes. So you give us the average stock out. Average stock out units per cycle or per order. Per cycle or per order. The only or expected. You see, average is the same as what here is the same as expect. Thank you so much. Goretti, we don't call them yet safety stock. We aren't yet there. We are still doing stock out, isn't it? But thanks for that. We're still doing stock out units. Been able to get the stock out, the disappointments. Now you want to average them. So in this case here, remember these are average or expected, stock out units. I'm not calling them stock out cost, but units. Yeah, per cycle or per order. And how do I get these figures? Already I can see Lavi has given me the figures. How do I get them? 450? I doubt. This Lavi person, what Lavi has done, I think Lavi has added this plus this plus this. You forgot in this case the concept of Tata. Tata, when you multiply the figures with what are their corresponding probabilities. So like, for example, for this 375, I can see the stock house, Tata plus Tata plus Tata plus Tata. So 0 times 0.4 plus 75 times 0.06 plus 150 times 0.04 plus 225 times 0.02. So is there somebody who is able to give me this? If I were you, I would write here working one, and then I go somewhere just for demonstration, because I will forget this. For demonstration, I can go and write working one somewhere there for my future reference. So like working one, I'm doing 0 times 0.4 plus 75 times 0.06 plus 150 times 0.04 plus 225 times 0.02. What figure are we able to get? Somebody is giving me a figure of 15, So then, having done this working one, are you guys able to do these others without doing any working? Yeah. So like for 450, the probabilities are the same. So we'll take 0 times this, plus this times this, plus this times this, plus this times this. Then give me an answer there. 1.5. Dominic tells me 1.5. My physical guys, I don't know whether you were able to get this. They're saying no, it is 6. They're saying that ninja. What did that ninja do to get 1.5? I would want to know what that ninja did to get one. You know, it's 75 because I know the others are 0. It is 75 times 0.06 plus 150 times 0.02. I think that 6 makes sense. Thank you so much. Oh, for the next one, thank you so much. For the next one, and then of course this last one will be 0. The last one there will be 0. The last one there will be 0. Now, ladies and gentlemen, you are the guys who are guiding me. Today, you are the guys who are guiding me. I've been able to get the average stock out units per cycle. What will be the next step for me? Yeah, we multiply this by the number of orders. And then you appreciate the fact that number of orders will never be given. I don't know even why these examiners are giving number of orders. Can somebody tell me in this particular case, if you wanted to get number of orders yourself, what would have you done to get number of orders? Thank you so much, Lydian. To get number of orders, in this case, Lydian is telling me that she would have taken, in this case here, the annual demand, and then you divide by Q or divide by EOQ. Anytime you want to get, you can write this just for the sake of it. Number of orders. We take D over Q or EOQ. Very important for you to remember that. Yeah, so in this case here, this examiner was very easy. So number of orders. So the number of orders they've given us in the question, they've told us we have got how many orders here? In note number 2, we have 6 orders. So you write here 6, 6, 6, 6. And then you go ahead and multiply. So that you're able to give us the total annual stock out units. They're still units. Next step. Thank you so much. Next step, yeah. Why are we multiplying with number of orders? Remember, whatever you got here was the average number of disappointments per reorder level. And reorder level is per order. Yeah, we have one reorder level cycle for each order. So normally we have as many reorder levels as number of orders, So next you have to multiply this with number of orders to get this total annual stock out. So the first one is supposed to give us 90, 36, and 9. 90, 36, and 9, and then 0. And then next, somebody has told me, look for stock out cost per unit. Look for stock out cost per unit. So stock out cost per unit, are you able to see the figures? For stock out cost per unit, are they able to see the figures? Yeah, it is 300. It's given in note number 1. It is 300 per bag, So that will be constant, 300 constant, 300 constant, 300 constant, 300 constant. So then are you able to give us that answer? I have to adjust my camera a little bit. So is there somebody? Yeah, already a ninja has given us 27,000. Total stock out cost. So a ninja already has given us 27,000. From there, the next one is 10,800. 10,800. From there, we have 2,700. And then lastly, of course, is you multiply the two numbers, isn't it? Yeah, for your revision, we multiply the two numbers. Yeah. Yeah, great. Great. Now, ladies and gentlemen, after you reach there, you can still use this very table. You can still use this very table to calculate your holding cost for safety stock. Is there somebody who can tell me how I'm going to get my, first of all, safety stocks? Anybody who can tell me my safety stocks? How am I going to get my safety stocks? Is there somebody who knows the formula for getting safety stocks? Anybody who could be knowing the formula for getting safety stocks? Yes, yes. So safety stock is very, very easy to get. And normally if you're using this approach, ladies and gentlemen, to get safety stock is very, very easy. Yeah, you can come and put it up here. I don't know whether you'll be able to squeeze it here or you want another table. If I'm the one doing, I'll squeeze it here. I'll be able to come and calculate here, the safety what here, safety stock. Yeah, please try to squeeze it. And the very best is simply to pick the number. This is the benchmark. Remember, the first one that you have here is the reorder point without any safety stock. So like the number 1 here, the safety stock here will be 375 minus the benchmark, which is 375, which gives me 0. For the next class, I know to get the safety stock here, I will take 450 minus the benchmark, 375. Here, I will take 525 minus 375. Here, I have 600 minus the benchmark, which is 375, which is 375. Let me just open up my lens a little bit. So remember, we explained this, and you can take this approach. This approach is very, very good. This approach is very, very good. You simply come write safety stock at the very top. Yeah. So how do we get these safety stocks? Safety stocks, remember that the very first figure given is a reorder point without any safety stock. Safety stock there is 0. And to get it, you simply take the same number minus 375, which is the smallest. So this smallest is what you subtract from each number that you're seeing here. So like when I go to the second one, I will say 450 minus the smallest number. So 450 minus 375 gave you guys what figure? Somebody's giving me a figure of 75. Is that okay? 75. The third one will give me what number? 150, right? The safety stock here is 150. And then the last one will be 600 minus 375, which gives me 225, like that. Now, if you're using this approach, you will simply come and write here, holding cost of safety stock. Holding cost of safety stock. Holding cost of safety stock. Do you have the holding cost per unit? Is there somebody who has a holding cost per unit? Anybody who has a holding cost per unit? Yeah, it is the carrying cost, isn't it? Remember, holding cost is the same as what you're carrying? Cost. So then this is at 50 per unit. And we know the safety, these are holding costs of safety stock. So like now the first one, the safety stock is 0. So it will be 0 times 50. This will be 75 times 50. This will be 150 times 50. The last one will be 225 times 50, like that. So the first one will be 0. Is there somebody who could be having the second one? 75 times 50. 75 times 50. I'm being given 3750. So I'm being given here 3750. I'm told him, Mwalimu, write 3750. This one I'm writing 0 there. How about 150 times 50? How about 7500, eh? 7500. The next one is 7500. 7500. And then the very last one is 225 times 50, which will give me what figure? 11250. So now you have 11250, and then now you come and give us the total cost. Give us the total cost. Total cost, which basically is a stock out plus what here, somebody? Holding cost. Plus holding. You add the two. You add the two. Again, I have to adjust my table. My camera, I have to adjust my camera a little bit. So basically, you take the stock out cost that you have up there. Yeah. And then you add these to the holding cost. Slowly. Just slowly. So remember, it is costing. So costing, you start here. All right. So you take 27,000 plus 0. So the first one is 27,000, right? The first one is 27,000. The first one is 27,000. The second one, you take this plus this. 14,550, yeah? 14,550. The third one, 10,200. 10,200. And then the last one, 11,250. 11,250. So then, ladies and gentlemen, which one is the very best cost amongst all this? The minimum one, isn't it? The 10? It is 10,200 is the least, isn't it? So 10,200 is the lowest. So this is the optimal cost. And therefore, this is the optimal cost. And therefore, optimal safety stock. Optimal safety stock will be how many units here? Remember, safety stocks are the ones on top. The optimal safety stock is 150. 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 Optimal safety stock now, it will be 150. And then, of course, the optimal reorder level will be what here, 500? Or the optimal supply? can call it optimal supply, will be 525. 525 will be 525. And there are ninjas who did this and got everything. There are ninjas who did this and they got everything. 150 is the optimal safety stock. Remember, these were the safety stocks. So the very best safety stock is 150. 150 is the optimal safety stock. And then the optimal reorder level is this one now here. Or optimal supply is 525. Yeah. So up to there now, ladies and gentlemen, are we together somehow? Are we together somehow? Can I ask you a question? What is the probability of stock out here? What is the probability of stock out? If you go by this recommendation, what is the probability of getting a stock out? Somebody give me an answer. Probability cannot be more than one. The probability cannot be more than one. I joined a bit late, Paul. I'll be able to show you in a moment. So if we say the optimal supply, we are supplying this 525, there is only one possibility of us running out of stock. If the demand is 600. So if they ask us for probability of stock out, that will be the probability of our demand being more than 525. The one that you have armed us with, the one that we have been able to stock ourselves. So in this case here, we can only get a surprise if the customers will be 600. And what is the probability of 600? It is 0.02. It is 0.02. It is 0.02. So up to there, ladies and gentlemen, before I explain to this ninja who came in a little bit late, are we okay? Are we okay up to there? Are we okay? So then I would want to give you 2 minutes. You copy the table very, very fast. You copy the table very, very fast. As I explain to this student how we got, first of all, the probability. You see my friend, the one who came in later, they have given us usage 225. There's a table there, 225, 300, 375. And they've given us number of times. Those number of times are our frequencies. We add the total frequency that we got as 50, and then to change them to fractions, we took 9 over 50, that's the probability, 15 over 50, and so forth. And so forth. So now that one with the video, of course, I'm so sure you'll be able to see how we came up with those probabilities. The last statement is about probability of running out of stocks. It's normally the very easy, the very easiest. Because you see, you have just advised us that we need to stock how many units here, somebody? We need to stock 525. So before I rub this, there is somebody who had requested that we show the bottom of this table. Have they been able to write? I want to rub so that I can explain that probability concept. That probability concept is a bit tricky. I want a green light to rub this. Tony says yes, but Tony, I know you're not the one who asked me to show the board down here. Yeah, all right then. So I think that is okay now. You see, like now, this is really a very, very potential area this semester. If I were you, I would repeat this. Don't assume that the way Mwalimu has been able to do it quite fast and easily, that you have understood it. No. The policy is, I know nothing. And even the nothing that I know it wrongly. You must create time later on and redo the same question. Don't even go doing many other questions. Just redo the same question and you will never, ever go wrong. You see, they want here, in most cases, they will ask you for probability of a stock out. Probability of running out of stocks. We can only run out of stocks if demand is more than what we have supplied. If demand will be more than what we are supplying ourselves is 525. So then we have only one possibility of demand being 600, of demand being more than 525. It is this one. So in this case here, this is the probability of demand being equal to 600, which then will be this 0.02 like that. So we only have one chance, one event, which we see ourselves running out of stocks, only one event. If we supply as per the optimal safety stock, if we supply 525, like that. Let me ask you students another question. What if our optimal reorder level was 450? What if our optimal reorder level was 450? And then in this case here, you are asked to ascertain the probability of stock out. If in this case, ladies and gentlemen, our reorder level, what we have recommended optimally is 450, and then you have a ninja asking you the probability of running out of stock. There are only two events, isn't it? So the two events, it's either probability of 525 or probability of what here, somebody? 600. So you simply add the two probabilities like that. You add the two probabilities because or means yes, add. Or means add. Or means add. Or means add. So can we go to now something serious? Can we go to something serious? So if you're asked in this case here, annual stock out in units, it's what we did in the table. The annual stock out units, you simply get the annuals, you get first of all the stock outs per order, number of orders, and then you multiply to get the annual stock outs for each. How do we get annual demand? It is given. You see, we are given there or right. I know what this student is asking. The annual demand, the examiner must give us the number of days in a year, which weren't given, and we don't need it. Because you see, I would have wanted this annual demand if number of orders were not given. Then I would have taken annual demand divided by EOQ. But here we are already given number of what here? Number of orders. Already we are given number of orders, yes. All right, my good students, if you allow me, I'll be able to go to what we call perishable goods. Perishable goods. Perishable inventory items. Remember the topic is inventory. Inventory. Perishable inventory items. And I would want us to write pole pole. This one we shall write. Where is this perishable? So perishable stock items or perishable inventory. We are writing there that perishable items are a single period items. These are a single period items whose demand is based on time. Whose demand is based on time. I.e., once their time lapses, then the product will no longer be needed. The product will no longer be needed. Will no longer be needed. So there are two situations there. If an item is perishable, after it perishes, you can either throw them away, or in this case here, you get somebody who can buy them at a throwaway price. Yeah, so these items include fresh flowers. So fresh flowers, which are time bound, which was supposed to be given to you on Valentine, anakuletea kesho kutwa. Hata maybe alipewa na mtu mwingine anakuletea sasa hiyo ime-expire. Yeah, fresh flowers. We have in this case here anniversary cards. Those are time-bound products. Time-bound products. Now, ladies and gentlemen, for us to be able to understand very well how we handle these perishable items, I would want us to look at an example for these perishable items. I would want us to look at an example. Just give me 1 minute. I get this example that I would want us to do. Newspaper. It's called newspaper. Just a minute. Where has this gone? Has it disappeared? We shall overcome. If it disappears, the class ends, and I'm so sure there's some ninjas. If the class was to end now, they will be very, very happy. They will be very happy. Perishable items are very, very common in your exams. You'll be able to see that. We normally use what we call marginal analysis. All right. So what we shall do as I get this question of a newspaper vendor, we shall take a break. I'll do December 2021. After I do that small illustration, we take a break during Muslim prayers, 10 minutes prayers. I will be able to get it for sure. Yeah, I'll be able to get it. All right. So we'll come back at exactly 7:01. Yeah. Perishable items are single period items whose demand is based on time. The demand is based on time. Yeah. I.e., once their time lapses, then their product will no longer be needed. Then these products will no longer be needed. And then we have an illustration. A newspaper vendor buys daily newspapers for 50 per copy. So the buying price is 50 per copy. If sold on the same day, they will sell for 60. If sold on the same day, they will sell for 60. If not sold on the same day, they are sold off the following day at a price of shillings 10 per copy. So this illustration is great. So we are told a newspaper vendor buys daily newspapers for 50 bob per copy. And if he sells them on the same day, he is able to fetch a price of Kenya shillings 60, the normal price. But in the event that he doesn't sell them today, in the event that he perishes with them, then we'll be able to get some funny characters who will be able to buy these newspapers tomorrow for a reduced price of Kenya shillings and per copy. So they've given us the demand. You can see the demand here is 110, 120, 130, 140, 150, 160. And then the probabilities are given. So required, determine the optimal number of papers to be stocked. We are writing this question on the board. We're writing the question on the board. Are you not able to see the illustration question on the board? The illustration question on the board is what we are writing. A newspaper vendor buys daily newspapers for shillings 50 per copy. If sold on the same day, They will sell at shilling 60. They will sell at shilling 60. If not sold on the same day, they are sold off the following day at a price of how much? Shillings 10 per copy. Then they have given us the demand. Yeah, they have given us the demand. They have given us the demand. Yeah, maybe this will be much better for you. So they have given us the demand. So the demand is here 110. Yeah, 120, 130, 140, 150, 160. Although this is supposed to be 0.1, eh? This is supposed to be 0.1 like that. Forget about the column of cumulative probability that I'll be able to teach you. And then now they want us to determine the optimal number of newspapers to be stocked. So now, have they been able to take down the illustration question? Have they written it? Have they written it? Have these ninjas written the question? We do it? Yeah. So the first thing that you're supposed to know is that this is a perishable good. This is a perishable commodity. However, I know it's a perishable commodity, that this gentleman will be able to buy these newspapers on the very same day. If he sells them, if he's lucky to sell all of them, then he'll be able to sell each one of them for 60 bob. But in the event that he's not able to sell them, these items will lose significant value. He will sell them the following day for only Kenya shillings 10. So then this is a perishable item. This is a perishable item. And if it's a perishable item, if it is a perishable item, if it's a perishable item, we normally use what we call marginal analysis. Marginal analysis. So under marginal analysis, you give us what we call the marginal profit. Give us what we call the marginal profit. If these newspapers are sold on the very day they are bought, how much profit will this gentleman make? How much profit will this gentleman make? Thanks, Lillian. Remember, the normal selling price will be 60 minus the buying price of 50, which will end up giving me how much? 10 bob. That is marginal profit, profit per unit. How about marginal loss? Marginal loss. So marginal loss means that he has been able to perish with them. Marginal loss, is there somebody who can give me the figure of marginal loss? 40, really? Marginal loss. All of them are saying 40. 50. 50. Remember, what have they told us, my good students? That in the event they are not able to sell this newspaper today, they shall sell it tomorrow for what price? 10 bob. 10 bob. And they had bought this newspaper for how much? The normal buying price, isn't it? The normal buying price. Remember, you have bought it for 50, but you're selling it for how much? For 10. Remember, ladies and gentlemen, that to get profit, you're looking at revenue minus your cost. So my revenue is the lower price I'll be selling, which is 10, minus my cost of procuring, which is 50. So then the loss will be 40. You see, ladies and gentlemen, you can't say that this company, Kenya Airways, has made a loss of minus 15 million. Once you use the word loss, you've taken care of the minus. Yeah. So once you use the loss, Rina, once you say loss, and Julius, ukisema jina loss, then this has to be the magnitude. You forget the direction. You forget the direction. And then now after that, you'll be able to give us what we call probability of success. Probability of success. What we shall be abbreviating as P. How do we get this P? To get P, we take marginal loss over marginal loss plus marginal profit. Please write this. Anytime they want us to get the probability of succeeding, yeah, we take marginal loss all over marginal loss plus marginal profit. Marginal loss all over marginal loss plus marginal profit. So is there somebody who is able to see this marginal loss? It is 40 bob. Don't use the negative. Ignore the negative. Ignore the sign. All over 40 plus marginal profit of 10. So then this will be 40 over 50, which will end up giving us what probability there? 0.8. So this gives us 0.8. So whenever it is a perishable good, under inventory management, we shall always use what we call marginal analysis. Give us marginal profit and you give us marginal loss. So marginal profit is 60 minus 50. We sell it on a sunny day, same day, 10. And then if in this case here, we don't sell it today, we sell it tomorrow, we will lose 40 bob. We'll lose 40 bob. So then we have been able to get this. And then now the next thing, so we've been able to get 0.8. The next thing is for us to give our examiner the cumulative probability of demand. So cumulative probability, actually call it reverse cumulative probability of demand. It's a reverse. It is the only area where we use reverse gear, reverse cumulative probability of demand. Fortunately, they have given us the demand figures. Fortunately, they have given us the demand figures. So the demand figures, I can see them vividly. I can see demand there is 110, 120, 130, zinafuatana 140, 150, and then 160 like that. And then they have given us probability. So probability here, it is 0.05, 0.1, yes, 0.0, 0.20, or 0.2, isn't it? This is not, if it was simulation, then I'll be concerned with that 0.20. All right. After that, we have 0.35, and then 0.2, and then 0.1. So could you kindly write that table up to there? Please write that table up to there. It's on the screen. You can even screenshot, or somebody can screenshot and send those students that question on WhatsApp. All right. So then come and now give us, because it's a perishable good, you give us what we call reverse cumulative probability. Reverse. Remember, in this case here, we want to succeed. Can somebody in this case here define success for us in light of a perishable item? If you're selling fish here today, and the fish will be perishing, in this case here, success for us will be able to sell everything. Success for us will be to have demand being higher than the supply. We would rather disappoint people. We would rather, in this case here, disappoint people here. We get, in this case here, our money in the pocket, yes. So you see, ladies and gentlemen, if I bring this lowest demand value, 110, then I'm assured of selling everything. Because you see, the very least demand is 110. So if I supply 110, then I'm assured of selling. Because if 110 customers come, I sell all the 110. If 120 come, I sell 110. I disappoint 10. So if, for example, I decide to bring the lowest, then in this case here, I'm assured of selling. So in that case here, I'm successful. Because these are perishable good. Perishable good, I look at my plight. I don't want to perish. I don't want to remain with these goods behind. I would want to sell everything. I would rather people go to other suppliers because I've disappointed them than me perishing with these units. The easiest way of you remembering this is not what I want to do here. If you want to get this very well, if it's a perishable good, always get your cumulative probabilities, but from down here, reverse. So then this one here will be 0.1. 0.2 plus 0.1, somebody will be point. Somebody talk to me. 0.3. So reverse, you start from down here. And this is only applicable. I've never seen it being applied anywhere else. We only apply this in perishable goods. So 0.35 plus this gives us 0.65. This will be point what here, somebody? Oi, 85, 0.95, isn't it? And then the last one will be what here, somebody? 1. If you wish, you can say 1.00, but I'm not concerned with those zeros because this is not simulation. So basically, whenever you want to get these reverse cumulative probabilities, which is an approach applicable to perishable items and then inventory management, I must accumulate these probabilities from down here upwards. But now remember, you have your optimal probability of success. Do you remember that figure? Optimal probability of success. Our P was 0. What here, somebody? 0.8, isn't it? Our P was 0.8. So please locate 0.8 here in this cumulative. My 0.8, I don't know whether your 0.8 is in between. My 0.8 is here. Is in between 0.65 and what here, somebody? 0.85, yes. So it means then I have to stock between how many newspapers? I have to stock between 130 and 140. But you see, the examiner will tell you using a continuous distribution. Continuous distribution has probability as decimals. So examiner would want you to interpolate. So at the end of the day, what you are telling our examiner that this ninja here selling newspapers should stock. So the optimal quantity to stock is 130 to 140 newspapers. But you see, now they want the exact number. They want you to interpolate. Is there anybody in this case here who will be able to interpolate this for us? ISO has forgotten how we got the 0.8, or it came a bit late. There's a formula we used. If you don't mind, maybe I finish doing the entire question, then I repeat. No worries, I can repeat. All right. So the optimal, the 0.8 is in between here. It is 130 and 140. Rearrange DD. No. You don't have to rearrange them. But of course, they will give you these figures like that, from the smallest to the highest. It will always come like that for perishable goods. Average, no. I like that. Average, no. Because you see, average now will be having 3 numbers. Because I know what you want to mean. Well, let me take 0.85 times 130 plus 0.65 times 140. How about this 0.8? Shall be hanging. Shall be hanging. 130 plus 140 minus 130, 0.8 minus 0.65, 0.8 minus 0.65, 0.85 minus 0.65. You have to be very careful. So, ladies and gentlemen, this is how we do it. This is how we do this. This is how we do this. This is how we do this. So to get, in this case here, the exact quantity with the decimals, because we're using a continuous distribution, remember we have discrete distribution and a continuous distribution. Continuous distribution, they have decimals. So the exact here, it will be this 130. This one, you start with the smaller one. Plus 140 minus 130. This difference is what we are interpolating. The difference there is what we are interpolating. Yeah, so in this case, the difference is what we are interpolating. Remember the higher times. So we have here numerator. Numerator will be the difference between these two numbers. Numerator. 0.85 minus 0.8, numerator. And then denominator will be this. Denominator will be this. So we have here 0.85 minus 0.65. Not the way, Lillian, you did it. Lillian, you took the lower arc. We always take the upper arc for the numerator. We always take the upper arc. So we take what is between 0.85 and the 0.65. Yes. Because you see 0.8 is in between the two. Is in between the two. So you take the two numbers. So 130 is the smaller one plus the difference between the two. Yeah. And then I will use this cumulative probabilities here, where the upper, the numerator here, you take this 0.85 minus 0.8 over This is the denominator, 0.85 minus 0.65. So then we move slowly. Let's move slowly here. So then this one will be 130 plus this is 10 times this minus this gives me 0.05. All over 0.85 minus 0.65. 0.2. So can you kindly give me the final answer here? Kindly give me the final answer there. Pauline is giving me 132. Lydian, yeah, 132.5. 132.5. Yeah. So he should stock exactly 132.5 newspapers. So when they tell you use a continuous probability distribution, you must interpolate. But if they tell you to use a discrete distribution, you advise them to procure the smaller number. Between 130 and 140, you advise them to procure 130, so that in this case, they'll be able to sell everything. Allow me to repeat something here. But first of all of us, before I show that Ninja will ask the question about how we got this probability of success, have we been able to get this figure of 132.5? 132.5, they want me to repeat, fine. Or we round off. Yeah, you know, if it's continuous, then you should be able to get up to the decimals. Don't round off to 133, no. Yeah, so we have yes. Because you see, the examiner will tell you using a continuous probability. I know you did this in QA. Difference between discrete. A discrete probability distribution is a distribution which can never accommodate a decimal number. So that one you give a whole number. But when they tell you it's continuous, like in most of your exams, they've always told that it's a continuous. So if it's continuous, we must write the exact number we get precisely. So the students who are not able to get this, I know it's because of body mass. You see, body mass, first we multiply. We say 10 times 0.05 over 0.2. Whatever answer we get, we add it to 130. We shall be able to get that 132.5. Yeah. Alternatively, let me show you another method. I'm so sure how we getting that answer. I'm so sure maybe students will be able to write, to understand this much better. The concept of similar triangles that you guys did in Form 3. Similar triangles. Yeah. So we have our quantity here. So this is 130. This is 140. We have our cumulative probabilities. Yeah, so we have here 0.65. And then we have a 0.85. Yeah, 0.85. All right. So of course we have this base like that. And then in between, we have a 0.8. In between, we have a 0.8. Eh? What am I trying to do now here? Let me see. Great. So let me just complete this. Yeah, so similar triangles. So I'll be able to drop this as a triangle, 90 degrees up to there. And then I have another base at 0.8 here. Yeah, similar triangles. And then this, I'll be able to drop this down up to X. Like that. So I don't know X. So I have this triangle, the big triangle, and then I have this small triangle, this one here. So big triangle, big one. Let me just label them A, B, C, and then I have my D there. Can put here E. So in this case here, triangle ABC is similar to triangle DEC. Triangle ABC is similar to triangle DEC. Just keep quiet a little bit. So then in this case here, what do we have? Let's compare their bases. The base of EC, this base here. So this base, it will be 140 minus X, the difference for this base here. All over the base of the bigger triangle. Bigger triangle, it will be 140 minus 130. Yeah, equals. Then again, we compare the heights. Let's compare the heights of our triangles. So we have the height of the smaller triangle. So the height of the smaller triangle can give me the height of the smaller triangle. 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 So the height of the smaller triangle, ladies and gentlemen, that I can see here is 0.8. 0.8 minus point what here, somebody? 65. 0.8 minus 0.65 all over the height of the bigger triangle. Height of the bigger triangle is what here, somebody? 0.2. Height of the bigger triangle. So can we kindly go slowly and get these things very, very well? Let's try this. Let's try this. Let's make x the subject of the formula. So if we make x the subject of the formula, then this one here will be 140 minus x, isn't it? 140 minus 130 gives me what figure, somebody here? 10 equals, what is 0.8 minus 0.65? 0.8 minus 0.65, 0.15, right? So this gives us 0.15 all over 0. What here, somebody? 0.2, 0.2, 0.2. So I want to make x the subject of the formula. I want to make x the subject of the formula. So to make x the subject of the formula, my good students, this will be 140 minus x times 0.2. Yeah, I'm cross multiplying. Will be equal to 10 times 0.15. So this one here will be 140 minus x times 0.2 will be equal to 10 times 0.15, which gives us 1.5. Oh, they're not following. So here I've got two options. The first option is to multiply each one of them, or I divide directly here. So I can come and say 140 minus x equals 1.5 divided by 0.2. So can somebody give me this quotient? Can somebody give me this quotient? 1.5 divided by 0.2 will give me what figure? 7.5. 7.5. I'm being given a figure of 7 point what here? 7.5. So then is there somebody who can give me the value of x, which is our interpolated figure? It must agree with our 132.5. Remember, we got 132.5. And this is a crazy method. Why would I want to remind you about these concepts of what here? Concepts of similar triangles are something that we did a long time ago. If I were you, I would simply master this concept of continuous probability distributions, where I'm given here my demand of 110, 120, 130, 140, 150, 160. Now that you have seen this method is complicated, but first of all, are we in agreement with x here is 132.5? Are we in agreement about that? Are we in agreement about that? 132.5. Yeah. So if I were you, I would actually even put there a big cross using a red pen. Say I will never even try to imagine about similar triangle in my entire lifetime because it is a simple method. So here I'm given probabilities. Probabilities, please read for me. The first one is 0.05. The second one is 0.1, 0.2, 0.35, 0.2, 0.1. So then you come and give us what we call reverse what here probabilities, cumulative. Reverse cumulative probabilities. So these reverse cumulative probabilities, you start accumulating them from down here. So we have here 0.1. When you add this one, it gives me 0.3. This gives me 0.65. This gives me 0.85, isn't it? When you accumulate, this gives me 0.95. Lastly, we have what here? And we must always end up at 1. Always. 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 So then after you have been able to get these cumulative probabilities nicely, remember your probability of success is which one here, somebody? Oh, I'm alone. Probability of success is 0.8, isn't it? Of the triangle. Just sit and leave the triangle alone. Just understand this. Leave those things alone. You can only see it's only Paul who is saying that he loves them. This is the best. This is the best. Don't be cheated by anybody. Just understand this and you clear. Trust you me. With exam pressure, you'll not be able to remember those similar triangles. You cannot. You cannot. Actually, I was even doing this similar triangle because I saw Lillian doing this interpolation in a funny way. Yeah. So once in this case here, you have known that your 0.8 is in between here. So you know that the newspapers to be procured are 120 and what here, somebody? In between 120 and 130, isn't it? So then the exact, how do we do exact number of newspapers? Exact number of newspapers. What do we have there? We start with a smaller one always, isn't it? Plus difference between the two numbers, 130 minus 120. And then from there, we do abracadabra. I know here, for the denominator, it is the bigger. Denominator is the bigger difference, the bigger arc. The bigger arc, which will be 0.95 minus 0.85. How about the numerator? The numerator, I would always use this upper arc. The upper arc. So the upper arc, oh, these guys are not able to follow. Is it 120? Ah, sorry. Yeah, 0.8 is not here. Look at what I'm doing. 0.8 is here, isn't it? Yeah, human is to error. 0.8 is there. Sorry for that. But again, you have learned something. Nevertheless, we have learned something there. So 0.8 is in between 0.65 and 0.85. It's a number in between here, isn't it? So we start this. So in this case here, the newspapers I will buy, they'll be between 130 and the one what here, somebody? 140. So we are talking of 130 plus the difference between the two numbers, 140 minus 130. Then I talk about my denominator. So denominator, we are looking at the difference between these two numbers. The bigger. Yeah, this bridge, I have to cross the bridge. Across the bridge there. So it will be 0.85 minus 0.65. How about the numerator? It is the upper arc. We don't cross the river. It is the upper arc. So the upper arc, what do I have here? I have 0.85 minus 0.8. So then this will be 130 plus this is 10 times. Now the difference here is 0.05 over 0. What your difference? 0.2. Now once you reach there, then you are at home now. Once you reach there, then automatically you are at home. This one you'll always remember it because of the reverse, whatever, you always remember it. But if of course you feel that the triangles are easier for you because maybe you completed high school the other day or you have done a degree in mathematics, you are good to go. All those are our methods. So when you reach here, always remember to take the multiplication first. 10 times 0.05 over 0.2, whatever answer we get, we add 130 to it. They've refused triangles, eh? They've refused triangles. They've refused triangles. We shall overcome. So are they ready? We go now to a past paper question. Are they ready? We go to a past paper question. I show you how this has been tested. Yeah. So then this past paper that I would want us to take, ladies and gentlemen, right now, it is this concept of sausages, which were tested a long time ago, May 2016, question number 3B. May 2016, question number 3B. And here throughout, I will be silent. May 2016. Yeah, about continuous. Continuous is where, like now what we have done here, we have gotten probability, or rather we have gotten an answer in decimals. Yeah, if they asked us about discrete, where they want whole numbers, then we should have recommended 130 newspapers without thinking about that decimal point. Because discrete means we don't allow decimal places. So May 2016, question number, May 2016, question number 3B. Have we gotten the question itself? May 2016, question number 3B. Have we gotten the question? Now, the student who asked about the marginal analysis, how we got that probability of success, they'll be able to understand when I do this question. Have you gotten it? Great. So we are told here, James McCarley prides himself as the largest sausage supplier in the city. small, freshly baked sausages are the specialty of his shop, I mean. He has sought help in determining the number of sausages he should make each day so as to maximize his long-run profitability. From analysis of past demand, he estimates the demand for sausages as follows. So you can see demand there versus probabilities. The selling price per packet amounts to 90. The cost per packet, which includes handling and transportation, amounts to 65. Sausages that are not sold at the end of the day are sold as day-old. Yeah, day-old rotten sausages the following day at 30. So required, ladies and gentlemen, using continuous analysis of probability distribution of demand, advice on the optimal production quantity in packets for the sausages. So remember, these sausages are perishable. Have you been able to see that? Yeah, because if I sell them normally on the same day, I buy and prepare them, I sell them for 90. But should I perish with them? Should they go stale? I'll be able to get chocoras outside here. I sell to them at what here? At 30. So it's a product whose value is diminishing with time. So then what will be the very first thing that I should be able to do? I know that there are students who are waiting for Mwalimu to do it. I'm not doing this question. This question is yours. This question is yours 100%. Our next topic is really, really interesting. It's known as budgets and variances. I love it. And that will be the last topic for us. Because already environmental management accounting, we said you watch some video. Have you been able to watch it? Oh, but are you connected to the LMS? Okay. Is there somebody online who has been able to watch that environmental management accounting video? At least Ken has watched, Lillian has watched, Dennis Dombi, great. Everybody shall be able to watch it because after this topic, we are doing variances, which I'll be able to take maximum 2 sessions, and then we start proper revision. Remember, we agreed, we signed a contract that this semester nobody is failing in this paper. Then I like what Harvey is telling me. We have a contract, nobody's going to fail in this paper. If you fail in this paper, and then we meet outside here, you'll allow Mwalimu to whip you 6 of the best. 6 of the best. No, 6 give you by. We have a contract. We have a contract. So we need to really do a lot of practice. At least now I'm happy because I gave 1 assignment yesterday. Yeah, and I checked 7. At least I saw 7 who did very well. But again, now most students have started doing these things. Whipping wamekataa. Whipping wamekataa. Dominic anasema 6 of the best na shaifanya, the joke to Dominic. We have to pray to God that everybody shall pass. AMA is not a paper you should fail, because if you fail, what I know, even here, let me tell you a secret, even here, there must be somebody who has failed this paper 6 times. Even here, if people were to be honest, 4 times, it's a bad paper. If you fail, you can't fail only once. I want to get somebody who is very honest. Tell us, in this case, if you have failed, how many of us have failed like 3 times, 4 times, without fearing anybody? We are mature here. By Kenyan government, okay. But it doesn't mean that if you failed last semester, you'll fail again. No. With me, nothing like that. Julius failed. At least this is an honest ninja. Opening stock tap? No, we don't want opening stock. Next semester, no. I don't want any opening stock. Oh, faithfully going? Peter, by the way, we miss you. Peter used to ask very good questions. No wonder, Peter, nowadays I don't see you. Please, for AMA, Peter, if possible, get to attend live sessions, especially during practice or audit. Okay, crazy, okay, crazy. We must pass this one here. So even if you failed last semester, we have to pass this one, especially now from today when I throw in one assignment question. Don't start staring at someone else's solution, saying that I would have done it like that. Who told you that you would have done it like that? Don't see if it's an assignment, that's your obligation. You just have to scribble. I don't want you even to be getting my assignments correctly. I just want you to scribble something and then send it there. Who will kill you? Nobody. Nobody's even paying your fees. I just want you to get knowing how to start tackling AMA questions by doing those exercises. And if you are bright, you'll be able to pass. Like there is one question that I've repeated many times, but I'm so sure there are ninjas who haven't seen it. This question of payoff table. The one in decision theory, we have one question here. Tumerudia sana. Tumerudia sana. Of course, I appreciate you guys are busy, demanding children. Like right now, they have closed school. Even myself, it's not easy. They had to make me miss a whole day tuition. Was it last week on Sunday? Yeah. But you see, that cannot be an excuse for failure. We can't fail. Hapa hata kama kuna mtoto ako 6 months, unasoma naye na nguvu. Unasoma naye na nguvu. Unamwambia dadi, lazima tupite sisi wote. Thank you very much for scribbling something you have tried, right? So long as you have tried, even if you haven't gotten it right, then I can do the question. So can I go ahead and do the question? Can I go ahead and do the question? Amelala, great. Thank you so much. Great. Thank you so much. So long as you have scribbled something, to me, that is really good because I appreciate you guys are very, very busy. It's about scribbling. I don't want so much from you. Yeah, at least Paul umefika 0.71. Is there somebody who has gotten 0.71? You can see, Paul, you haven't gotten out of this with nothing. You've gotten something. You've gotten something for sure. I've marked AMA for so long, and I can tell you, not many students in AMA papers are able to know how to start doing questions. If you look at last semester, when we were marking these scripts, most of the scripts were blank, totally blank. That is why I want you to be attempting whichever question I tell you. I want you to just attempt to scribble something to see how you will be able to get started in an exam. If you know how to get started, then you'll be a genius. You'll be able to pass this paper. So first, we get probability of success, probability of being able to sell everything. So this probability will be marginal loss over marginal loss plus marginal profit. So this MP is marginal profit. Equation of my sausage, the normal selling price is 90, isn't it? And then of course we are buying and transporting everything at how much? 65, 65, eh? So marginal loss, do we have this poor selling price? The bad selling price is how much? 30, eh? If we don't sell it today, we shall sell it tomorrow for 30 bob. But you see the buying price, the seller does not want to know when you will sell it. The seller charged you upfront, how much? 65. So the first one, you guys never gave me an answer. What is the marginal profit? The first one, 25. Is that okay? How about the marginal loss? Here you'll now get a ninja putting negative. Marginal loss is what here, somebody? 35, because it's a loss. So I only consider the modulus. So then this probability of success, it will be marginal loss, which is 35 all over marginal loss which is 35 plus marginal profit of 25. So is there somebody who is able to get that 0.71 that ninja got? Ah, that 0.71 ilitoka wapi? Nyinyi mlipata 0.71? Mlifanya makosa gani? Mlitumia 90? No, sijapata mlitoa wapi hiyo? Sijapata. Na mimi nilikuwa na CIFA namba sana. So inafaa kuwa 0.58. Yeah. But now at least if you made a mistake, let's work with two decimal places. If you made a mistake, then you are able to learn, isn't it? That is the most important thing. Yeah. So from there, we have the reverse gear cumulative probabilities. 0.58 is correct. Thank you so much. So then come and give us the reverse cumulative probability. Sorry. Have you guys been able to write up to here? Thank you so much. So the reverse cumulative probabilities. So you need the demand. So we have the demand here. So we have here 1800. We have 2000. We have 2200. We have 2400. We have 2600. We have 2800. We have 3000. With the probabilities given. Probabilities, we have 0.05, 0.10, 0.20, 0.30, 0.20, 0.10, and then we have 0.05. So please don't write your normal cumulative probabilities. They have to be inverted or reversed. We call them reversed. Or inverted cumulative probabilities. So we start from down here, right? So this will be 0.15, right? The next one, we are teaching together with you. 0.35, 0 point, 0 point, 1. Thank you so much. Or 1.00, regardless, yeah. If the last one does not add up to 1 in an exam, take a red pen and just put a wrong for yourself. Mark for yourself wrong. The last one must be 1. Must be 1. And then now you come and fit in the 0. What here, somebody? 0.58. 0.58. So at this juncture, do you want us to start drawing triangles? Do you want us to start draw triangles? That ninja called Paul who said triangles are nice. No, no, no triangles. No triangles. No triangles. Yeah. So go ahead and give me the exact, because they want you to use the continuous probability distribution. They want you to give them an exact decimal. Yeah. So I'll give you a minute for you to, so in this case here, the stocks should be between 2400 and 2600. So if they want us to use discrete distribution, then we use what here, somebody, the lower number, 2400. But if they want us in this case here to give them, continuous, then we go ahead and interpolate. It's called interpolation. So how do we interpolate? Very easy. So it is 2400 plus 2600 minus what? All over, in this case here, we have the upper cut. This is the upper cut for the numerator. For the numerator, thank you so much, Peter. 0.65 minus 0.58. All over, the lower cut is bigger, 0.65 minus 0.35. So then this one here will be 2400 plus, the difference there is 200, right? What is 0.65 minus 0.58? Somebody give me an answer. Peter nowadays is very tough, eh? Peter nowadays, there must be a secret. There must be something that he's really doing. I believe he's telling us that he's doing audit. 0.3, right? 0.3. All right. So then are you able to first of all multiply? Or if you have a good calculator, you say 2400 plus 200 times that divided by that, you'll be able to give us an answer. You'll be able to give us an answer. 2446.67, isn't it? Yeah. Also, whenever they use this terminology of continuous probability distribution, you can opt to convert this distribution into a normal distribution. Give us standard deviation, give us the mean, and then I use that normal curve. You'll get an answer that is closer to this. But whenever they ask about continuous, this is the approach they want you to use. You get all the marks. There's a ninja up there who asked how we got to 35. If you allow me, then I'll be able to just show them how we got this marginal loss and the marginal profit. So marginal profit, normal selling price minus, in this case here, our buying price, which never changes. Yeah, when you talk of marginal loss, this will be reduced selling price minus our normal buying price, like that. So then marginal profit, yes, Ken, you're right. Yes. Starting the question normally is the problem. So you can see the normal selling price is 90. You can see the normal selling price there is 90. And of course, we had bought this for 65. For 65. That is how we got, in this case here, that 35 profit. Is it 35 or 25? 25, eh? 25. Profit of 25. And then if we don't sell these sausages on the normal day, first day, sausages that are not sold at the end of the day are sold as day old. I won't eat this for 30. So it will be 30. Buying price is normally the same. So 30 minus 65, that's how we got a marginal loss of 35. Ladies and gentlemen, it has been lovely hosting you tonight. I'm looking forward to meet you in our next session. Bye. Yes, the script would have been 2400, the lower one, to avoid disappointments. No, if it's discrete, you give the lower one. See you. Great, ninjas. Bye.